Good afternoon, good evening. Can I just get a voice check, please? Is the voice okay? Okay, perfect. Awesome, Aaron. Thanks, mate. I appreciate it. So welcome to the class, everyone. Let me just put the camera on so you can, so you know that I'm not AI. But I put the camera on because to prove that I'm not AI. That's the only reason. So that I'm a real person. So Michael, welcome. That is very true, Michael. Yeah, but Michael, trust me when I say this, AI cannot make a video this ugly, right? It's not possible for AI to make ugly stuff like this. Although the way they make, you know, the way they do hands and fingers, that's pretty ugly. So maybe I've got a chance. I could be AI. I could be. So now, Michael and Tran and Aaron, can I get you guys? Aaron's already checked. Can you check your inbox for the survey for this unit? And anyone who's watching this recording, there's only a couple more days left to do the survey. It's really important for us if you can do that survey. I know it's annoying. I'm not a big fan of survey. I don't like. Let me rephrase that. Hi, Tran, and hello. I know how annoying surveys are, but this is kind of important. I want to make sure that I want you to all be happy and positive though. So just double check that if you can, Tran Ann and Michael. And by the way, we fixed a little minor issue. So we did lab 4 last week. And the reason why is because lab 3 and lab 4 are exactly the same. So I got it fixed. So now we did lab 4 accidentally last week because it was titled lab 3. So now we're going to do, so we've done lab 4 already. We're going to do lab 3 instead. Okay, no, there's no big deal. There's no issue here. Easy. So I've loaded my let me just get rid of that because I don't need that anymore. So I've got the lab up and running. And if you go into your notes, sorry, not your notes, your module, you'll see that this has been updated. And the new lab, if you download it, you'll get the proper lab this time. Cool, excellent. So we'll do that now. So this is the lab here, and this is all about the static analysis of code. So remember what I mentioned last week, that with static code, this is all. It's like if I was to write some code, right, and I've got like 50, 60 lines, yeah, I could do it myself, really, to be honest. I could analyze it myself. 50, 60 codes, yeah. That's fine, Trina. That's perfect. That'll be okay, but no worries. That's fine. I'll make sure that that's all taken care of. Yeah, Michael, though, it's honestly, don't stress too much. Just submit lab submit lab 4 as lab 4, okay? Because I know I'm aware. If you've already done it twice, it's okay. I'll sort that out. So just update this one. So lab 3, this one that you're doing now, upload that into lab 3. Actually, no, upload lab 3 into week 4, and I'll write notes on it so that you'll be okay. I'm marking these anyway, so I'm giving you a complete or a competent on that. Yeah. Now, so as I was saying, yeah, this is it. So with basic static analysis, we want to find high-level information about an unknown file, okay? Now, we want to, so there's a couple of ways with this. If we're not running the code, if we're not writing it, sorry, if we didn't write the code, then it's very difficult to see what that code is. It's very, very difficult. We have to reverse engineer it, right? It's very, very hard to do, but there are some tools for like applications that are not very advanced, just basic applications. There are ways. So what we want to do with a static analysis is we do not want to execute it. Okay. We don't want to execute this file with the static code. Very, very important, because if we execute it and it has a virus in it, then the virus will deploy. The payload will deploy and do whatever it's supposed to do. If we don't have the code and we don't run it to do it, like last week, remember we did the dynamic analysis where we ran it in a sandbox environment or in a way where it's not going to infect anything else. So if we can't run it and we don't have the code for it, then how do we analyze it? There are a couple of tools. There's a tool called Detected Easy, Strings, and CFF Explorer. They kind of in a way do some basic reverse engineering of very, very basic programs. Let me just mention to you this way. If you get Adobe Photoshop or Microsoft, or like these huge applications that, hundreds of megabytes or terabytes application, it's not going to work. They're just too big. But with our keylogger example, we'll be able to put the file into Detected Easy, and Detected Easy will not run the file, but we'll have a look at it. We'll have a look at that application and see if there's anything in there. It's just a tool. How they write this tool, how they develop it, it's beyond my expertise. It's just a tool that they've developed that can have a look at what's in the file. Okay, but remember, it's static. It's not running it. It's just going through the file, just having a look at it, see if there's any malicious code in there. Okay, now let's go over to, so we're going to extract the lab 3. We have to go back in here, which I think we've done already, right? Oh, no, we haven't. We did lab 4. So let's do lab 3. I should have picked up this last week, actually. I should have noticed that. But well, we'll be okay. What was the password to this file? It should be the same as last time. I forgot. Infected. Thank you, Trana. Thank you. Infected. Beautiful. Thank you. All right. So now we will copy that. Oh no, we don't have to. Look, it's there already. Perfect. All right. So that's where that's where it's located. So I'm going to copy that. And what we'll have to do is we'll have to find the tool so that we can have a look inside it. And that's DI. Yeah, okay. Yeah, that's right. Sorry, I've just got my wires crossed. All right, yeah, so DIE. Let's have a look. I'm just going to type D. There it is. It's DIE, die. So we'll run that. I just noticed that was die. I never really noticed that before. All right, we'll go and locate it. I've copied the what do you call it? The file location there, and I'll enter that, and then I'll open it, and it will scan this application, see what it can come up with. Okay. Actually, I should have done advanced. Okay, let's I might I'll just stop that. I'll go to advanced, and then I'll scan it. Actually, I'm just going to escape that. I'll do that again. Okay, perfect. I don't know why that was so quick at that time, but all right, great. So we've got some stuff happening here. What do we have exactly? Well, let's have a look at what the lab's asking of us. The program extracts a lot of valuable information from the PE file headers. With the default setting of the tool, you can see various information about the file, such as the file type, the endianness, the mode, the architecture, and the type of program. Our sample is recognized as a PE64, which means it's a 64-bit portable executable file. So long as we're running it on a 64-bit machine, we can use it across the different, like Intel or AMD. Okay, and we can see the compiler and the linker. So what compiler is it? The compiler, it'll be C or C++ or Visual C to be precise. So let me get my Zoom It tool up and running. Tran, I don't think so, do we? Does it ask us to? It doesn't, but do it anyway. Why not? You can remove it, and yeah, perfect. Go for it. Do it again then. You're going to get the same results, but you do it anyway. The reason why if you change that, the anti-malware might pick it up. It might stop you. Might delete it. It depends. What was I saying? Oh yeah, that's right. Oh yeah, yep. I'm just getting my Zoom It tool. Okay, beautiful. Okay, so now, yeah, so it was compiled, it was written, it was compiled in Visual C or C++, and that's the language. And the tool that they used was Visual Studio. So it's a Microsoft environment where they created this, and it was done in Visual Studio. There you go, it's got an AMD 64, and all that means, it only means that that's a 64-bit architecture. It will work on Intel as well, Intel 64 bits. There's the operating system. Oh, heaven forbid, Vista, one of the worst operating systems in all time. It had some good features, good innovations. It just wasn't really supported properly. Okay, now what are we looking at next? So beautiful, excellent. We've clicked the advanced. The information extracted and shown in advanced analysis mode are categorized in various parts, such as file info, memory map, these SM, whatever that is, hex, and so on, shown in the below screenshot. Okay, so this information here, we can have a look at. It gives. There's one over here that I just noticed, signatures. That looks interesting. Virus total, interesting. Yeah, we might have a look at that later on. Let's have a what do we need to look at exactly, I wonder? Click on the file info. All right, let's go to file info. Where is it? Where is file info on this? File info. Can't find it now. I had it before. Where are you, file info? Oh, there it is, right there. Okay. So there we go. It's got information there. I can't really expand that. But there we go again. It shows you the size, the operating system it was developed on, created, AMD 64, 64-bit, and Dianis, which is LU. Perfect. So far, so good. This lab is going nice and smoothly. Let's click on the hash part. You'll find hash values of the values of the file itself, as well as individual sections. Why? Because knowing the hash value of a section can help quickly recognize files with the exact same section. I'm going to explain this. This is important. Click on hex, and you'll see these different sections here. These are all hashed signatures. And this is important here, when we have anti-malware, or when we have an endpoint EDR. I keep forgetting the acronym, endpoint desktop something. Basically, it's a whole security solution. And also with our firewalls, our application, our WAFs, if it detects a signature and it matches the hashed files of that signature, then it will know. It would have seen it before. It would have seen it before in another virus or another malware, or it will have a database somewhere. This will be located on a database, and then it will stop it. That's how antiviruses a lot of times stops the malware from running, because it will observe the hashed values of these signatures. Like we're doing this manually, okay? But the anti-malware will actually look at this automatically. If it sees a string of hex values, which is exactly the same as what it has in a database, it will block it. And you can go down and keep looking. So these are just patterns. It's like DNA, right? So for example, in a murder case, they'll find DNA blood samples or skin samples or something, and they'll analyze it, and they'll get the DNA, and they'll get the DNA sequence with all of this stuff that you can see jumbled up here. They'll have a look at a DNA string, and then compare it to the defendant. If there's a match, they can use that in court if it's properly done. Same thing. We're doing a live DNA test in a way. Lots and lots of strings here. Lots of string of hexadecimals. Lots of not hex. My bad. I'm really sorry. My brain is. I'm still in. I had a big day today. I mean hash, not hex. I mean hashed. These are the ones. These hashed values. Okay, they're the ones that the anti-malware will look at. Each section of code has a specific hash value. And if that hash value is in a database, an anti-malware database, then it will do something about it. It'll block it. That's what it's looking for. That's the DNA of that application. We're going to get there, don't worry. And of course, we can change the hash value, because not all of our anti-malware uses the older types. So let me put it to you this way. If I have, in this scenario, it's Vista, it could be SHA-1. I don't think it's going to be SHA-512, because in those days it could be. So if our modern day anti-malware doesn't look at MD5 hashed algorithms, it could be an issue. How is your knowledge about hashing in terms of cryptography? You know that a hashed value is just a DNA. It's just a signature of code. It's not encryption. You're not encrypting and de-encrypting data. Perfect. That's good, Michael. Well done, mate. I'm feeling happy. This is like a proud moment. You know why, Michael? No one understands the difference between hash and encryption. Well, when I say no one, not everyone gets confused. They believe you can get a hashed value, and that's an encrypted value. So you got 20 terabytes and you hash it. People still believe you can reverse that. You cannot. It's just a DNA. It's just a signature. If you've got that, man, you can focus on other stuff, more important things now. Beautiful. I could not have said it. I try to say it that way, Michael, and people don't get it. So I don't know. But the way that you say it, you should trademark that. Trademark it. The next one is click on the strings to find all the strings present in the file. So where the string would be found in memory. So this string value, I know we're getting a bit technical here. We're getting into the realm of programming, into application security. We're getting a bit deep here, but we just need a high-level view at the moment. The string value, if this application was to run, this is where this particular string would be found in the memory. If this application ran, it would then go and grab memory from the PC, and that is where a string value would be found in a memory. Let's have in a memory location. Let's have a look. So if we go to strings, so if it was to be run, if it was going to be run, this string value would be found in this memory location. How many of you out there are doing programming? Anyone doing C or Python's really, it's scripting really, but you can do programming. Anyone? No? No C, no C++? What about a little bit of Python maybe? You should learn Python. JavaScript is okay. It's okay, but scripting, my advice, Michael, learn a little bit of JavaScript. That's good. It's always handy. I would learn Python, and you know what? If you can just learn a little bit of C and C++, they're pretty similar. C++ is like C, but it's just got object-oriented programming in it. Because the themes of programming and scripting are very similar. The if statement, if when. So Aaron, the reason why Python is incredibly important to learn is in Windows we have PowerShell. So in Windows we have PowerShell, and we also have I forgot the old DOS space, but not many people use anymore. But we've got PowerShell. In the Unix environment, we have Bash scripting. So if you're in a Linux, you do Bash scripting. If you're in a Windows environment, you do PowerShell. If you know Python, you can run it on both. It will run on Mac OS as well. It will run on anything. That's why, and Python scripting. So what I mean is, like, for example, if you're in Windows, and if you've got 500 users that you want to create, you can do it in PowerShell. That's probably what you'd be doing anyway. And so you've got 500 users that you want to add an Active Directory, and you have 500 users in a Linux system. So like a file server, you want to give those 500 users access to a folder in a Linux system. Yeah, you'd have to go into PowerShell, and then you'd have to go into Linux and do these scripts separately. If you know PowerShell, so if you know Python, you can run them both. Now, don't ask me how to do it. I haven't figured that out myself. Programming scripting I know how to do it, but doesn't come naturally to me. I have to work really hard. I have to take my time with and make sure I get it right. But anyway, learn scripting. Python's a good start. And Aaron, it is really easy to learn Python. Yeah, C is good because that's where programmers create programs in C. If you want to create a program, if you want to make programs, it's done in C and C++, but C is where it's mostly done. But you learn concepts that when an application is run, created in C, C++, whatever, it's asking the RAM in your system, it's saying to the RAM, I want to put this data, this string of data, into this memory location. Why is this important? Well, if this is a virus, if this is a malware, in this location, it might hijack that location. It might keep it forever, and we might not release it. So what will happen is you could go into that memory location with other tools and have a look at this location here. And if you see some interesting behavior, or if you see that it hasn't been released in hours and hours and hours, even though the application has been closed, you've got malware. That is really, really oversimplifying it. Michael, I've got a resource you can look into. I'm going to show you how I learned Python. And there's a bit of irony. This book is amazing, but it's funny. It's called, I don't know if you can see it in the camera. It's called Learn. Actually, sorry, wrong one. It's called Learn Python 3 the Hard Way. You see it? I'm going to write it down. And anyone who's watching this, just go to Amazon or Google it. It's called Learn Python 3 the Hard Way. It is a funny title for it. It's sarcasm, Aaron. It's sarcasm. They're being funny. They're like me. They've got my sense of humor. I've got a warped, really strange, warped sense of humor, and I like it. But forget the name. Forget the stupid name, the retarded name. Forget that. But the actual content in here is unbelievably brilliant. You do not know how to. You don't need to know programming at all to start getting value out of this. It's not technical. It's not jargon. They're just saying, let's just start programming. Let's just jump into it. Very, 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 very good book, that one. So there's another one. The other one I had is an extension of that. I completed all of it. This is years ago, 4 or 5 years ago. And yeah, I created a Python script where I can. No worries, Aaron. The script that I created was I could crack four character hashing algorithms, hash values. I can crack any password that has four numbers or letters. I can crack any hash value of those. It took about a week though. It was fun though. I just let it running for a week. Okay. So what are we doing here? Yeah, so this is where the string would be found in memory once the file is executed. Remember, we're not executing it now. This in the section or the header, which the string is found in, blah, blah, blah. The keylogger malware collected the captured keystrokes in a text file. Remember that when we ran it last time? Yep. The string found here shows the name of the file and the keylogger that's used to save the captured keystroke. Click on the entropy to find the total entropy of the files. So what does entropy mean? It's a really strange word. And I am sorry, I don't know how to explain it to you. So I'm going to use my best friend. You know what? I'm going to use Copilot. I usually use ChatGPT, but I found ChatGPT a bit weird lately. So I'm going to use Copilot. Use my Swinburne account. I don't know why this is not coming natively. It's pushing me to the web page. Anyway, explain what entropy is in the context of programming. Remember, you have to, when you're asking AI a question, and it's a good tool. I like AI as a tool. You must make sure you give it the correct context, because entropy is different, has a different meaning in other things. So there's different. There's one in cryptography. There's an explanation in data compression. The one we're looking for is entropy in programming languages, designed to embrace randomness and imperfection. Okay. Here's something interesting. I want to teach you all with programming. It is almost virtually impossible to create something with our CPUs at the moment where it is pure randomness. Okay, we cannot create something that's completely randomless and without logic, like illogical randomness, which would be truly random. CPUs have to follow logic. When there's logic, we can't create randomness, but we can do entropy. And basically what that means is that it's sort of like it's trying to make it as random as possibly. If it's got high entropy, then it's closer to what pure randomness would mean, even though we can't get there yet. Okay, so it's just, you know what, just stick with the word randomness, that'll be fine. That'll do it. So it says indicates a level of randomness. High entropy means that if it's more than 6.5, it means that if it's got a lot of entropy, it means that there's some encryption in this section and file. And that's interesting. Why is there encryption in there? So let's have a look at the entropy. Entropy, I can't pronounce the damn thing. All right, let's have a look at the entropy. I just forgot where, oh, they're up here. Up there. And what's that saying? So if we look at this one, it's not that packed. You can go by string, and it shows you a bit. Anything above 6.5, it's saying, means that that's probably encrypted, and it's probably something naughty. Click on each of the following parts. So we're going back to the left, and we'll see if we can get some more information here. You get some things like image file header, timestamp data. There's a lot of stuff that we can see without running the program and without even reverse engineering it. There's still a lot of valuable information here. And the anti-malware tools use this to help make decisions. So I'm going to leave that for you guys to explore on your own, play around with it, and see what else you come up with. So I'm going to go to sections to see a list of sections in the program. If I can find it, just over here. I don't know why the developers of this DIE program couldn't make this bigger, but anyway. And what we're looking for is we're looking for a hashed value. Sorry, not a hash value. Sorry, the number of the string. So basically, each section we can have a look at the file, the raw data, the pointer. I know there's a lot of things going on here. We're just showing you that once you get really good at programming and really good at application security, come and use these tools, and then it'll make a little bit more sense as you get more experience in this stuff. All right. So answer all these questions. In which offset the string? So which offset is that located at? So you've got to find that out yourself. I'll leave that to you guys to find that. All right, now that's DIE, okay? All right, so that's the DIE. There is another tool that we can use, and that's called strings. And guess what? Sysinternals. Again, it's just an amazing tool, Sysinternals. Seriously, download it. It's got everything. It extracts all of the ASCII and Unicode strings present in a compiled file. So the file is compiled already. Remember, we're not running it. It's just the file, an executable file, .exe. Excuse me. It's just a compiled file. It's just a file that we've created some code and we've compiled it. That executable file it's just a file. It's doing nothing at the moment unless we double click it. Strings inside a file can reveal valuable information about the file itself and what it does and how it works. This is what malware does. How does malware find stuff? Showing you now. Depending on the type of malware we deal with, these strings can include file names, file paths, domain names, and IP addresses. So I'll give you an example. If an application is run and it's malware and it's keystroke, a keylogger, it will send your keystrokes to an IP address, a command control center. How does it know where to send it to? Well, the IP address is in the file, in the exe. So let's go into, we'll use this. So we'll go to the command line, and we need to find our way to, yeah, it absolutely is train, absolutely, yeah. But just remember something, again, this is a very, very basic executable, really basic, low level. It's not modern day anti-malware, sorry, modern day malware is going to be more complicated than that. Not always, but just remember that you might not be able to use these tools. We're just taking baby steps. You have to learn how to walk before you can fly. I learned that from The Karate Kid, by the way, one of the greatest 80s movie of all time. All right, what do we do? We're going into command, and I like to run as administrator just out of habit. We might need to use that, and then I'm just going to drag this to the side a bit so I can see what I'm doing here. I need to go into the directory where sysinternal is. So I'll go to CD users. I think it's that. Yeah. So CD users, CD student tools, sysinternals. Now, if you're doing this on your own computer, okay. Am I doing a typo? System. Let's do a list. Not list. Duh. I did write students. Oh, whatever. Directory. So I used to be a PowerShell person. Then I swapped over to a Bash person. Sorry, Linux. Bash. I get my Y's mixed up here. All right. So what are we looking for? We are looking for sysinternals. Where is it? I don't think it's there. Student. Oh, tools should be on. There it is. Tools. All right. CD tools. The good thing about Microsoft. Oh, sorry, not list. It's dirt. The good thing about it is it's not case sensitive. It's good and bad, but. And then we'll go to change sysinternals. Great. So if we go to, okay, so we can see all these applications that we have in sysinternals. So hopefully you've got this downloaded and you'll use this on your own machine from now on. All right, now we are going to run this. We're going to run the application called strings dot 64.exe, and the path is I think I might have it still. I really don't want to type this out. Really don't want to type it out. And I don't have to, just copy. Just when you can just copy it and then right click next to the exe, it will paste it in there. Run that. I'll just agree to that. No matching files were found. All right. Okay. You know why? Because I didn't type that that file itself. Okay. Let's do it now. So I have to do some typing. It looks like. Lab 3 key. You can tab, by the way. Tab makes it life easier for you. Hit that enter, and it's going to run through that for us. But that's a lot of stuff. I don't know. I couldn't read that. So let me do this instead. I'm going to tap the up button, do the pipe symbol, which is shift, and the backward slash, which is I think that way on your cameras. The backward slash, a shift, backward slash, which is the pipe symbol, and type more. And that makes it slows it down. I can just look through this bit by bit, and I can just press space, and I can have a look for stuff. So this is an ASCII value. Hopefully I can see something interesting. So I can see, look at that. Swin keylogger. Well, there we go. We now know that this is this is malware. I didn't run it. I just put this through this command line interface. I know that it's what do you call it? A malware. Who would name keylogger if it wasn't a malware? But that's a clue. We need more evidence. See if we can find more stuff here. And it's got all this stuff accessing kernels. Very dodgy code here. Very dodgy ASCII code. I'm looking for an IP address. I think. Are we? I thought we would get an IP address. Try using different options to see how strings are extracted from the file. Let's try some extra switches. So I'll just tap the up button, and I'll just push this over, and I'll do this space N20. So this will exclude strings that are shorter than 20. I don't want small stuff because they're useless to me. It filters things out. So I still got that. So it cleans it up a bit. Okay. So let's look for specific strings now. You know what? I think I've got a feeling that we have to run the file first. We have to run the executable first, I believe. Let's try this first anyway. We'll try this and then we'll run it, see what happens. So I'm going to go up button. Instead of more, I will use find str and log. If I don't find this, okay, it means that I need to run this, I think. Isn't it? File log. Yeah, it's, oh no, actually no, there it is. No, it's there. No, wait, I typed that, didn't I? Yeah, I probably need to run this, I think. I'm going to just quickly run it. Let's just run this. Just going to exit that one. Exit there. Going to just quickly run it. Okay. Rename. All right. I'm just going to change that. And then run it. And then I'm just going to type something now. I'll get Notepad. So it's recording my keystrokes now. All right. So there's that log there. Okay. Oh, Michael left. I just noticed that Michael disappeared. Okay, no worries. So let's do this again. We'll run that again. No matching files. You know what? Because I changed the name here. I changed that. Still didn't work. Okay. All right, so we got that. That's good. Now let's try that again. Still not happening. Okay. I'm not sure what's happening here. I might have to find out exactly. unless, yeah, that's strange. That's really weird. I'll change that back to that one. Got the log text there. Okay, we'll try that again. Yeah. All right. No worries. Leave it with me. I'll see if I'll find a solution for this. Okay. Perfect. So let's use another tool. We're going to use another tool called CFF Explorer. This one, leave it to me. I'll find out how to fix this, how to get this lab working properly, and I'll update you. Oh. So one more tool, and that's it for today. There is there's a little bit more of a section on advanced static analysis. Have a go at that and let me know if there's any issues with that part. I might need to do a video on it. All right, let's go to CFF. So it's just there, CFF Explorer. It's got that pepper. And let's open the file there. That one there, and then open it. Great. Passes all the headers and executable files. Yeah. Import. So we want to click on import directory. There's some APIs there. Wow. So these are all the libraries that this. So when we compile this in Visual Studio, Visual Studio is grabbing some libraries and putting it into the code and compiling it together. That's how we make applications. So we don't have to create our own code. We can borrow from a library. So this import directory is going out and grabbing some libraries, and this is what's being used. This is the kernel library, user32 library. Just saves having the coders to recreate them. We can see an API function. So these are little doors, windows that we have access for this program in and out, like little portals that we can send configuration into and send configuration out of the programming. And we can also we can use this tool to see the raw content of the compiled file in ASCII. Highlighted in, so we go to hex editor over there, and this is the raw code. We are looking in particular for MZ up here. Up there, MZ, and we're looking for 4D somewhere. 4D, 5, yeah, up here, there it is. So that is normal for a Windows executable file. That's normal. That's how we know that that Windows needs to execute this. However, this is a tool that allows you to manipulate the contents of the file and rebuild it. That's interesting. That's a bit like Wireshark. Wireshark does that with the network packets. We can rebuild it, but this is we can rebuild stuff here. Yeah, there's a possibility that we can break this, but if we rebuild it and then. All right, excellent. That's all I will go through today. Is there any questions? Any issues? We've only got 2 people left, Aaron and Tran. Any questions so far? Any issues? Anyone's watching this video later on, please reach out to me through the discussion group, or I've got a Discord server up and running if you want to ask questions. But other than that, we might call it a day. All right, guys, I'm going to end the recording and I'll see you next Tuesday. Thank you very much. Ending the recording now. Yeah, sure. Aaron, I've ended the recording. Go for it. My pleasure, Tran. You're welcome. You have an amazing day. Don't forget the survey. Please fill out the survey.
Hey Harry, can you hear me? Hello?
If you want, Aaron, you can take the mic, or you want to type. It's up to you.
Can you hear me? I'll test this.
Oh, hang on. Sorry. I might need to.
Hello, hello.
Okay, yeah.
Can you hear me?
Yeah, I can hear you. Yeah, thank you.
Okay. So Harry, I wanted to know more about like Python specifically. Is it like I've heard it's useful for like cybersecurity in terms of like the workplace. That would probably be one of the
Yeah.
most useful ones.
So,
Yeah.
so basically, okay. So if you've got, say, for example,
Yeah.
your part of your job, you're in cybersecurity, and you've got
Yeah.
daily tasks that you have to run every day.
Yeah.
You can type those. You can go into PowerShell
Yeah.
or the Bash Windows, Linux, and you can individually type those tasks, or you can run a Python script, and that's good for pen testers. Let me give you an example.
Yeah.
I'm going to get one up for you now. I'm going to get ChatGPT to create one for us. So create, and this is why ChatGPT's AI is really good. Create a Python script to scan, to use Nmap to scan a network, to scan, scan a network.
By the way,
With
so I can't see your screen.
oh, okay, hang on.
And I think it says it's still recording in process.
Oh,
I'm
is
not
it
sure.
really? Okay, let me end
I'm
that
not sure.
recording.
It's by
I'm
accident
going to end
or.
it now.